Hello everyone, my name is Gu Chunping. I'm from Zhejiang University of Technology in China. The title of my presentation is The Effect of Sulfate-rich Sewage sludge ash on the volume deformation and the microstructure of cement-based materials. It contains 4 parts. Firstly, it is a brief introduction. Then, we will talk about the raw materials and the methods. Afterwards, we will have some results and discussions, and finally, the conclusions will be given. Sewage sludge is a residue which is generated in the wastewater treatment process, and it is very difficult to deal with. Sewage sludge is normally disposed at the landfill or at the sea, and it is sometimes treated for the agriculture uses. But due to the health reasons and the environmental concerns, these methods are now becoming less acceptable. And at this time now, the incineration method has become more popular because it can reduce the volume of the sewage sludge by 90% and reduce the weight by 70%. Sewage sludge ash, SSA, is the residue of the sewage sludge incineration process, and it can be recycled in construction materials such as bricks, light aggregates, cement, mortar, and concrete. In China, the sewage sludge ash is normally sulfate-rich because during the pre-treat process, a lot of chemical agents are added in the sewage sludge to improve its dewatering ability, and these chemical agents contains a lot of sulfate. Normally, the sulfate in cement-based materials will cause volume stability problems. So the aim of this study is to review the possibility of recycling use sulfate-rich sewage sludge ash in cement-based materials. So we studied the effect of this ash on the micro properties, especially the volume deformation and the microstructure of cement-based materials. The raw materials in this study included the cement, the sulfate-rich sewage sludge ash, fine aggregate, and the water. And from the table, we can see that the sulfate content in this ash is more than 23%. So there are a lot of sulfate in this kind of ash. Here are the mixed proportions used in this study. We prepared the cement pastes, and the sulfate-rich sewage sludge ash contents were 0%, 5%, 10%, and 15%. The water-to-bond ratio was 0.5, and the paste specimens were used for the microstructure studies. And we also prepared the cement mortars. We also have 4 ash contents, and the water-to-bond ratios were 0.4, 0.5, and 0.6, and the sand-to-bond ratio was 3. We did a lot of tests, which include the fluidity tests, the taking time, the strength, the Autogenius shrinkage, dry shrinkage, potential expansion, and we also did some microstructure study, which includes the XID, TGDRC, and MIP analysis. For the volume deformation tests, we tested the the volume deformation of the mortars under different environmental conditions. So for autogeneous shrinkage, it was a sealed condition, and for drying shrinkage, it is a drying condition. And for the potential expansion tests, the specimens were immersed in the water, and we tested the length change of the specimens. This is the test results for the fluidity tests, and we can see that the addition of this ash reduced the fluidity of the cement mortar, and more ash resulted more fluidity reduction. Here are the setting times results, and we can see that with the addition of the sulfate-rich sewage sludge ash, the setting times of the mortars was retarded. And this is due to the presence of the zinc and phosphorus element in this kind of ash. This is the test results for the compressive stress tests, and we can see that with the addition of sewage sludge ash, the compressive stress of the cement mortar is reduced, and the more ash caused more stress reduction. And it is the same results for the fracture stress tests. More sewage sludge ash results in more fracture stress reduction. So when we recycling use this kind of ash in the cement-based materials, we have to take care of the stress reduction. Here are the test results for the autogenius shrinkage. We can see that before the age of about 3 days, the specimens expanded because of the presence of the sewage sludge ash. And after about 3 days, the specimens continued to shrink. And finally, the autogenius shrinkage was reduced by the addition of the sewage sludge ash. This is the test results for the drying shrinkage. And we can see that with the addition of sewage sludge ash, the dry shrinkage of the cement mortars was enlarged, and more sewage sludge ash caused a much higher drying shrinkage. For the potential expansion, we can see that if all the specimens were immersed in the water, they all expanded, and also more sewage sludge ash caused more expansion strength. So it might be true that the sulfates in the sewage sludge ash will cause volume stability problems to the cement-based materials. So we did some microstructure analysis, and this is the XRD results. And from the last figure, we can see that with more sewage sludge ash, we can see more Autogenius and less calcium hydroxide. From the results of the TG tests and the DSC tests, we also can see that more Autogenius was formed in the cement paste with more sewage sludge ash. So actually, the formation of the Autogenius was the reason for the expansion during the volume deformation tests, such as the autogenius shrinkage tests and the potential expansion tests. This is the results for the MIP tests, and we can see the pore size distributions of the cement paste with different contents of the sewage sludge ash at different ages. And we can see that with more ash, the porosity of the cement paste increased. So this is the reason for the reduction of the compressive strength and the fracture strength. and it is also the reason for the enlarged drying shrinkage of the cement mortar. Here we come to the conclusions. So the addition of the sewage sludge ash reduces the fluidity, retard the setting times, and reduce the strength of the cement mortar. And the addition of this ash caused expansion before the age of 3 days during the autogenius shrinkage tests and reduced the late age autogenius shrinkage. The dry shrinkage was enlarged when sewage sludge ash was presented, and it caused expansion when the mortars were immersed in water. And when this ash was added in the cement paste, hydrogen gas was generated and the porosity was enlarged. So these are the reasons for the change of the micro properties of the cement mortar with sewage sludge ash. Okay, thank you very much for your attention.